Hello, sir.
Yeah. Hello. Good evening.
Yes.
Yeah. Okay. So we'll start the webinar in a moment. So by the way, my name is Prakash. I'm the math tutor for this webinar. Hope you're doing well. Yeah. Just a second. Okay. Maybe a 30 seconds or
Sir,
so.
I'm doing well.
Yeah. Good. So let's see if anybody joins. Okay. Let's wait for another 1 minute or so. Okay. Okay, so we can start the webinar now. So I hope you guys know the today's topic, isn't it? Yeah, so I hope you guys know the today's topic. Today, we're going to discuss about the quadrilaterals, okay? The basics of quadrilateral and the types of quadrilaterals and those are, okay? So especially the polygons, the types of polygons and the angles in polygons and all. Okay, let me share the screen. Yeah. I hope you can see the screen, right? So the quadrilaterals for grade 8, for class 8.
Yes.
Okay. So quadrilaterals, which is nothing but the quadrilateral, the four-sided shapes. Okay. So before going to the four-sided shapes completely, let's learn the basics of 2D shapes. So what is polygon? The first thing. What is polygon? The polygon is a two-sided shape, okay? So all the two-sided shapes are called as a polygons, we can say. All the two-sided shapes are called a polygons. And which means what? At least if the shape has at least 3 sides, then it is a polygon. So which means the triangle is a polygon, the four-sided shapes are polygons, and more than four-sided shapes, five-sided, six-sided, heptagon, pentagon, hexagon, octagon. So all are polygons. Okay, the polygons are the 2D shapes which has at least 3 sides or 3 angles, we can say 3 interior angles. Okay, I hope you understand that. So the next one, what are the types of polygons we have generally? So we have more types like two-sided shapes, three-sided, not two, three-sided shapes, four-sided shape, five-sided shapes, and so on. Or else we have a circular shape such as circle, oval, or else semicircle. But generally speaking, we can differentiate the polygon into two different ways. One is regular polygons and irregular polygons. What do you mean by a regular polygons? Irregular polygons, the sides, all the sides in any shape, all the sides of a shape are same. So if you take square, all 4 sides are same. So that is a regular polygon. If you take a hexagon or a heptagon or octagon, so we have a same side length for all the sides which we have in that shape. So that is a regular polygon. Irregular in a sense, so each and every 2D shape has a irregular shapes or irregular polygons where you can't see the same length of the sides of all the sides, I mean to say. Okay, you can see the basic diagram there. I hope you can see that the regular diagram, how it looks like. All the sides are equal, or else we can say all the angles are equal. That is nothing but a regular polygon. Irregular polygon, still it has the same sides, same number of sides, but the length of the sides are differ, or else we can say the angles also differs. So that is the irregular polygons. Okay, so now let's try to figure out what are the total or complete types of 2D shapes or polygons. So these are the basic types. Okay, so that generally you generally classify it's a triangle, it has a four sides, then it is a four-sided shape, that is a quadrilaterals. That's what we are going to discuss today. Okay, and then five-sided shape is called as a pentagon, six-sided shape is called as a hexagon, seven-sided heptagon, octagon, nonagon, decagon, and dedecagon. It goes on. Okay, so we just try to learn up to 10-sided shape. And other than these three-sided shapes, we do have a circular shapes. Okay, let's go to the whiteboard and let me explain. I hope you can see the whiteboard. So other than the one which I was shown in that chart, in that slide, we have a circular shapes. What do you mean by a circular shapes? It looks like a circle shape. So that's a circle. Or we can say a semicircle, which is nothing but a half of a circle. And one more important one, which is oval or ellipse. Both are same. Okay, so these are the circular shapes other than the 2D shapes which we learned. Okay, so these are a circular based one. The other ones, it's based on the number of sides. So please let me know, guys, if you have any questions so far. Okay, so then try to learn the angles in polygons. I hope you know we can say we have two types of angles. One is interior angles, the other one is exterior angles. Angles in polygons. Okay, so you can take any of the shape. Okay, so let's take a triangle or a diamond in this case, for example, like this. So in this diamond, this shape had four sides and four angles. See, the angles which I have marked inside the diagram are called as interior angles. So these are interior angles. I hope you know that, right? Interior angles.
Yes, sir.
Yeah, the angles outside the diagram. So what do you mean by, for example, if you're extending the line here like this or something, let me draw precisely. Yeah, like this. So then this angle is there, right? So this angle, or else if you want to write few more, you can extend any of the lines. Okay, so to create a, see this one, or else you can say if this extends this line. Okay, so all these are exterior angle. Yeah, exterior angles, exactly. So these two basic things you need to remember. So interior angles and exterior angles inside the diagram and the outside the diagram. Okay, so I will explain a little briefly of all these things, just a second. Okay, so let me share the definition for you. Just have a look at that. The sum of the interior angles in a triangle is 180 degree. I hope everyone, I mean, you know that. And to find the sum of interior angles of the other polygons, we can make the triangles using, I mean, in another other polygons, and then try to figure out how many, I mean, what is the total angle. So this is one method, but this looks a little complicated. So let me explain the easier way. So using formula way. Okay, what I mean to say, Yes, welcome, Joseph. Okay, so we were discussing about the quadrilaterals. So especially I have just started the angles in polygons, Joseph. So please join the class. Okay, so what I mean to say, for example, this is a rectangle. So how to find the sum of angles, or rather we can say what is the total angle, sum of total angles in a rectangle or in any shape. So just try to break this or find a triangle in this. Okay, you can see that we have one triangle here, another triangle here. So we know that sum of angles in a triangle is 180 degrees. Since we have two, so 180 plus 180. So this rectangle has a 360 degrees. Okay, this is a basic way of doing. If you take a pentagon or a decagon, whatever, we just need to break down the polygon into triangles, and then each triangle has 180 degrees. So add all to get the total angle in any polygon. Okay, but this is a one method. But we do have a one more method to solve. Okay, so let me explain that. That looks easier for an extent. Okay, just a second. So we were talking about interior angles, which is the angles inside the diagram, inside a shape. Okay, so in any of the shape, any of the 2D shape, how to find the sum of interior angles? Sum of interior angles. How do you find that? For example, if I say what is the sum of interior angles in a triangle, you guys know that it is 180. If I ask you what is the sum of interior angles of quadrilaterals such as square or a rectangular parallelogram, you guys know that it is 360. But what about the other polygons? So we need to use the basic formula, which is n minus 2 times 180. Okay, so this is a basic formula we can use, where n is nothing but the number of sides. Number of sides. Okay. Okay, so let me check if I have any shape here. Okay, so let's take just a second. Give me a second. Okay, I will try to draw. And one more thing, this formula is applicable only for the regular polygons, which means when all the sides are same. Or yeah, it's not about regular. We can use for any, especially this one. Okay. So I will explain what I mean to say. Just a second. Okay, so I hope it looks a pentagon. Regular pentagon. Please assume it's a regular pentagon. So it has 5 angles, guys. Can you please, anyone tell me if you know what is the total sum of interior angles? So if you add all 5 angles, what will be that? Joseph, do you have any idea? Amira?
What, sir? Pardon?
How to find this sum of interior angles in this pentagon?
So there are 5 sides, so you could do is 5 minus 2, which is 3 into 180.
Yeah, exactly. Okay. Pentagon, which means 5 sides. N is the number of sides. So 5 minus 2, which is 3 times 180. What is 3 times 180?
540.
Very good. So the total angles, we can say sum of angles in a pentagon is 540. Amira, do you understand that? Okay. Please let me know, Mira, if you have any questions. So the next one, so please unmute, okay. So you just learned how to find the total angles or sum of all the angles in any polygon. But how to find each angle, so this applicable only for the regular shapes, okay. Each angle of a polygon, okay. Each angle of a polygon. So how to find it? For example, this, let's take the same example, which is a pentagon. How to find, or rather, what is an angle? What is each angle of a pentagon? So the total angle you got 540, and each angle is, it has 5 sides, so you need to divide by 5. Okay, so which is each angle as 108 degrees. Okay, so the formula, the same one which we use for the total, but you need to divide by n. So n minus 2 divided by n times 180 degrees. So this is to find each angle of a regular polygon. That polygon can be in n number of sides. It can be any. Okay. So I hope you guys understand. Okay, so which means, so each angle in this regular pentagon has 108 degrees. Okay. Yeah. So let's try one question. So please, you can try if you want to. So please tell me sum of interior angles in an octagon. Sum of interior angles in an octagon.
1280.
Okay, so octagon has how many sides?
8.
Yep. So 8 minus 2, 6 times 180. Okay, let me confirm that, which is 180 times 8 or 6, right? Okay, 1080, right? You said
1280.
280. Okay.
Yeah, 1280.
1080.
No, Joseph. I think we'll get 1080.
1080.
Yeah, because 6 times 18 is 108, right?
Yeah, sir.
8.
1080.
Okay, that's not a problem. Yeah. So this is the total angles. Okay. Yes, Amira, you're right. Good. And this is the total angle. But can you please tell me what is the each angle? Each angle of an octagon.
1080.
Divided by, that is the total angle. Okay, the sum of all the 8 angles is 1080. What about each angle? To find the each angle, we need to divide by the total number of sides. Yeah, so that is, if we divide that, please check. We'll get 135 degrees. Okay, so I mean, this applicable only for a regular octagon. Okay, which means all the sides are equal, only when all the sides are equal. Okay, so these are the two formulas you guys need to remember. One is subtract the total number of sides minus 2, then multiply by 80, and then to find each angle, just divide by the total number of sides.
Okay, sure.
Yeah, I hope that's fine. So let's move to the next type of questions, or rather next topic. So this is the formula I was talking about. Okay. Let's quickly have this. So how do we get that? Okay, we are going to use the formula. Okay, the same thing. So the pentagon we tried. I think octagon we tried 1080 and 135. Okay, so all the sides is the same thing. Okay, sometimes we might ended up getting a decimal answers as well, Joseph. And as you see for a octagon, but so we need to round that value based on the question, based on the given instruction in the question. Okay, sometimes. But the formula, if you want me to write it again, so n minus 2 times 100 to find the total, and to find each angle, n minus 2 times 80 divided by the total sides, which is n. Okay. So please let me know if you have any questions. Else we'll move to the actual quadrilaterals or maybe exterior angles. Any questions, Samira? Okay. So before we go to the quadrilaterals, so let's try the exterior angles. So we just learned the interior angles, how to find the interior angles of all the polygons, okay, any type of polygons. We learned the total interior angles, which is sum of interior angles, as well as the individual interior angle. What about the exterior angle, which comes outside the diagram? So that's what we learned just. So how it looks like, okay, if you want me to write, so it's better to take a triangle, okay. Just a second. Yeah. If you want to extend further here, we can do that. Maybe this line would be a good idea. Yeah, here. Okay, so everyone knows that the interior angles are this one. Okay, so let's call, I'm just randomly taking here. Maybe let's call this as a 60. This looks 60 and this looks 50. And let's say this is 70 then. I mean, total add up to 180. So this is the interior angles. What about the exterior one? The angles outside the diagram. So this one, the pink color one, which I'm drawn, this one, even this one. So this one, we can draw one more here. And if you extend the other side, I mean, in this way, like this, we do have another angle, another type of angles. Okay? So all are exterior angles. So you might have a question. So how to find the total or a sum of exterior angles? So how to find the sum of exterior angles? So before that, please have a look at the definition, guys. Let me write it here, the definition, or maybe in a different slide. Yeah. Yep, just have a look at this definition. So in the side of polygon is extended, the angle is formed outside the polygon. Okay, so that is nothing but an exterior angle. So this is what you need to write if you get a question. What is exterior angle? So and we have fixed value for all the polygons, which is the sum of any exterior. I mean, sum of exterior angles of any polygon is just a 360. It doesn't matter what type of polygon it is, how many sides it has, it doesn't matter. But each polygon, sum of exterior angles of each polygon is 360 degree exterior. And finally, adding to this, how to find the each angle. Yeah, let me drawing that. Each angle, which is 360 divided by the total number of sides in a polygon, the number of sides in a polygon. Okay, so this is how we need to find The angle. But one thing, you just need to consider the one way of. You are not supposed to consider. Let me draw it in a different color. We are not supposed to consider where it is. Yeah. See, we are not supposed to consider this entire thing. We need to consider only one portion. Okay, so like this. So then only, I mean, those angles add up to 360. So I mean, the sum of all the exterior. Okay, let's try some questions instead of the explanations. Let's try the same question here. I mean, let's see if it is possible. So we know the interior angles of these triangles, but how to find the exterior angles? So this one, the 60 degrees one. So this one is an opposite angle to 60 degree, vertical angle. I hope you guys know that the vertical angles are equal. So which is nothing but the opposite angles are equal. Okay. So you know that this is looks like a complete circle here. So which means 360 degree. So 60 plus 60 take away 120 take away 360. So we left with 240. So which means this angle is 120 and this angle is 120. Amira, are you able to follow me? So this is how we need to find the exterior angle. Yeah. And similarly, if you go to the any other side, 70. So this is a vertical angle, which is an opposite one, 70. So that's the same as 70 degrees. So how to find this one and this one? So you know that's it's a total is the 360. It's a split. It looks like a circle as you see, and a full circle I mean. And then 70 adds up to 140, and we're left with how much? 220, right? So which is this angle is 110, and this angle is 110. So what I mean to say previous page. So this one, okay, let's take the different color. So what I mean to say, why 360 here? The sum of the exterior angles of a polygon is 360. So that's what you can see here. So, but you need to take only one portion, okay, or else you can take the total portion. So that's a 360, or else you need to take any portion. So for example, 70, this 60, and then if you do this, we'll get 50.
See, this is number.
Okay. And take this one. Okay, so that's what you need to take this one. So if it is 50, what would be this one then? Take away 180, 360, 260, I think 130, right? So 130, 130. So what is 130, 120, and then in one angle we have 110. So you can see that we'll get 360. That's what it means, okay? So this is exterior angles of a polygon. Yeah. So any of the polygons, so it's always 360, the sum of angles. Yeah, I think that's it of the polygons, the exterior angles. So, but let's try one questions. Maybe let's take an hexagon if possible. Do we have a shape? No. I'm just drawing roughly. Okay. I hope it looks not bad. So let's assume it's a regular polygon. So you're extending the lines like this. Just a second. something like this. Okay, so I hope you guys know what is exterior angles now. So how many sides this has? This has 6 sides. So can you please tell me what is the sum of interior angles? What is the sum of interior angles?
So n minus 2 into 180.
Yeah, exactly. So 6 minus 2 into 180, you mean to say? So 6 minus 2 is 4. 4 times 180 would be like 720, I hope. So what is each angle? Each angle is divided by 6, right? What is 72 divided by 6? I think 12. So 120. So each interior angle of this regular polygon is 120 degrees. 120 degrees. So what is the exterior angle then? Any idea? So one thing, we can calculate the exterior angles using the interior angles. Else we can use the formula, which is the total exterior angles. Okay, the sum of exterior angles is nothing but a 360, and each angle becomes how many sides we have. That's it.
60, sir.
Yeah, exactly. Very good, Joseph. So which means each exterior angle is 60 degrees. Okay, so maybe you get a question without a diagram. What is the each angle, each exterior angle of a polygon, each exterior angle of a octagon, hexagon, and all. So you just need to divide the 360 by the total number of sides. It's a very straightforward. Okay. So I'm done with the exterior and interior angles. So please let me know, guys, if you have any questions.
Clear, sir.
Okay, yeah, that's good. So then let's move to the quadrilaterals. So that's our topic today, though. So the quadrilaterals, which is a four-sided shapes, which means it has a 4 sides and 4 angles. And we just learned what is the interior angles, sum of interior angles of a quadrilaterals, which is 360. I mean 360 for interior angles, and same as the exterior angles. So each side, it differs based on the length of a side, or else we can say a slant of a side angle. So what are the properties of quadrilaterals? These are the basic properties, guys. It has 4 sides, which is nothing but edges, and the vertices, in a sense, points, corners, coordinates, you can say. So it has a 4 coordinates. If we take any of the quadrilateral, it doesn't matter it is a regular or non-regular, irregular. So it has 4 angles, 4 sides, and 4 corners, which is nothing but coordinates. If you're mentioning or if you're drawing in the graph. Okay, and the interior angles add up to 360, and the exterior angles add up to the same as 360. Okay. So each angle differs based on the type of quadrilaterals. So I hope you guys know what are types of quadrilaterals quickly. So these 6 types are the basic types of quadrilaterals, guys. The square, the rectangle, the parallelogram, rhombus, trapezium, and kite. So these are the basic 2D shapes, or rather basic the quadrilaterals.
They are the 4 types of side shapes.
Yeah. I didn't get you, Amira. Okay. And you can see some diagrams below there. So rectangle as a rectangle has right angles, 4 rectangles. I mean, one rectangle has 4 right angles, which is 90 degrees, same as a square. Rhombus differs, but it looks like the right angles. In the parallelogram, each angle differs, but opposite angles are same as you see. But trapezoid, we have a two ways of regular trapezoid. We don't have a regular something. We can say equilateral trapezium and isosceles trapezium. Okay, so we got a chart. Quadri means 4, laterals means side. Exactly, I think before you joined the class, I was saying the same, Joseph. Yeah, exactly. The quadrilaterals, in a sense, the 4-sided shapes. So the lateral, in a sense, as you rightly said, is a sides. So 4-sided shapes. And kite, I think you can see that how it looks like. So we'll discuss each one of them. So on trapezoid, trapezium, so that's different. I mean, the wording we use in different countries. Then, so what is square? I hope before square, so this is how we used to find the area and the perimeter of a polygon or a quadrilateral. So area is nothing but we just need to multiply side into side, specifically speaking for a square or a rectangle, which is nothing but the area is nothing but the total space inside a shape, right? This total space inside the shape. You can take any of the shape. Okay, so that's an area. So since it's a 2D shape, it's a flattened one. Okay, for example, you can take a garden which has a rectangular garden. Okay, for example, or else a rectangular room which you are sitting now. So just assume, so the area is nothing but the complete space occupied, but not about volume. Volume is the complete space which we can feel how much thing we have inside the room. Okay? Inside the room, for example, if you take the room, for example, but the area is nothing but the base one. Still, since it is the, what do you call it, the flat shape, 2D shape, we just need to assume only the surface. Okay, that's the total space occupied in a room is nothing but the area. And the perimeter, you guys know that it is the distance around the room. You can say, if you take a room as an example, which is nothing but the distance around the shape. It can be any type of shape, any 2D shape, any polygon. So we can say sum of all the sides, all the exterior sides, external sides. Yeah. So that's the distance. Okay. So if you get like a garden, for example, how much fence required, I mean, so you need to calculate to purchase how much fence it required for the garden. So how do you calculate? It is nothing but the total distance. You will calculate around the ground, which is distance around the garden rather. So that's the perimeter. Okay, perimeter is also called as the circumference for circular shapes. For example, if we have something like oval or a circle or a semicircle, we are going to use circumference instead of perimeter. I think both are same. Okay, which is same as the distance around the shape. And yeah, the formula, as you all know, sum of all the sides around the shape. You just need to find the distance. And units, since it's area, we need to multiply the length and the width, or yeah, side and length or something. So we'll get the square units. So, but perimeter, it's a distance. So our distance is always calculated in units, right? Like meters, or inches, or feet, or whatever. Okay. Let's quickly go through the properties of all the quadrilaterals. The square, 4 sides, 4 corners. All the sides are equal, so which means it is a it is a regular polygon. So you need to mention that. And opposite sides are equal. Rather, we can say all sides are equal instead. And the 4 angles we have. So each angle is 90 degree because each angle is the right angle. You can see that. And interior angles, as I said, we can use this formula. I mean, how 360 we got? We just learned, right? How to find the sum of interior angles using n minus 2 into 180. So the perimeter is a simple one, and the area just need to multiply the side and side. The rectangle, guys, so rectangle, it looks like this, and it has a 4 sides, same thing, and opposite sides are equal, and opposite sides are same, parallel, equal, and it's same. And you can see the difference there. And the 4 angles, each angle is 90 degrees, as you can see again. And the same thing, interior angle add up to 360, because 360 it's quadrilateral. So obviously all the interior angle is add up to 360 for all the quadrilaterals. And the area formula and the perimeter formula, just have a look at that. Okay. And we have a separate formula for a perimeter, but I just mentioned some of sides. And the parallelogram, you can see it's slightly slanting, right? Like compared to the rectangle. So that's what it says. Just have a look at this, same thing again. But here we don't have a right angles, which is each angle is not a 90 degree. So it differs, maybe a less than 90 or more than 90, but opposite angles are equal, as you see here. The opposite angles. And I hope you guys know what is opposite angles and adjacent angles. So let's quickly explain that, or revise that rather. For example, this is the line. So one intersecting line, for example, see the adjacent angles, the angles which is next to each other. For example, 1, 2, if I say, and this one is a 3, and this one is a 4. What are the adjacent angles here? The 1, 2, or else you can say 2, 3, or else you can say 1, 4, or a 3, 4, which is next to each other. Okay, and what is opposite angles? Opposite angles is nothing but the 2 and 4. So opposite angles are also called as opposite angles. Yeah, are also called as vertical angles. Okay. So please remember that the vertical angles is nothing but an opposite, which means the vertical angles is always equal. So in any of the polygon, in any of the case, whatever the case you take, so if you get a word called a vertical angles or an opposite angles, it's an always same, okay, always equal. Okay, so that's what angle 1 is equals to angle 3, and angle 2 and angle 4 are equal. And adjacent angles, sometimes adjacent angles add up to 180, but it's not necessary. But we can say the angles which is next to each other, 1 and 2, or 2 and 3, or 3 and 4, or 1 and 4. Okay. Okay, guys. So I mean the class is going a little slow. I mean slower in a sense, the theory topic. So let's try one question and make it interactive. Just a second. So maybe it looks out of our, the topic, but that's fine. Let's make it a little interesting. Yeah. Oh, I just need to draw a different one. Okay, just give me a second.
Okay, so let's okay. The angle.
Sorry.
Angle was okay.
Sir, I didn't get you.
Never mind.
So let's say this looks like a 30. Okay. So this looks like, you can find that. And let's say this one is 40. So you guys need to find, rather we need to find this angle. Let's say this is X and let's say this is Y, and if you want we can say this is Z. Okay, we need to find these three angles. So can you please suggest me like how to find this, if you know, Joseph and Amira? Any idea like how to find the angle XYZ here?
Sir, it's interior angle or exterior angle?
No, it's completely interior angles, yes, you see, because I have mentioned XYZ are even given angles are the inside the diagram. So obviously it's interior angles. Yeah.
Sir, I'm not sure. Is it alternative angles?
Which one, X and Y?
No, sir.
No, it's not about alternative angles. So which means one after another, you mean to say. But here you need to use the triangular, interior triangular rule to find the angle. So first thing, you are going to find the X here. So that makes our job easier. So just take this portion. This is a right angle triangle, isn't it? So which means we can find the unknown side. So what is the X value, Amira? Amira or Joseph, anyone is fine.
Sir, 30 plus 90 plus X is equal to
180. So sum of three angles is 180. So what you said is 90 plus 30 plus X equals to 180. And you know that if you want me to calculate precisely, we'll do that. So 180 and X equals to how much? Take away
50.
120. 60.
Sorry, 60.
Okay. Yeah. So which means you're going to write the angle X is 60 degree. So the angle Y is not given, angle Z is not given. In the other triangle, in the below triangle, you can see only one angle is given, but how to find the other two? So just listen carefully, I will guide you. So just learn in the previous page. So can you see an opposite angles? So how it looks like, the opposite. If the angles are opposite, then those are equal. You understand that? So which means here X and Y are equal. You understand, Amira? So X and Y are equal.
Yes,
because those are opposite angles, or else you can say a vertical angles opposite. So 60. So now I think you can find the Z value easily. What is the Z value? I think you can find easily now. What do you think, guys?
180 minus 100.
Yeah, 60 plus 40 is 100. So we need to subtract 100 from 180, guys. So that's an 80, right? So you're writing 80 degrees. So angle X, Y, Z, all these things, three things will be found. Okay. Okay. Would you like to try one more question, or we'll go to the quadrilaterals? What do you think? Shall we try one more?
Okay, I will.
Okay. So I will draw the same diagram again. Maybe a little crossed one. So one thing you understand is it's a right angle. So let's say this angle is given as how much it looks like. It looks like a 45. 40 is fine. 40 degree. And this angle is given, which is 110. Yeah, 110, guys. So that's it. Nothing is given. You need to find the remaining. Okay. If you want me to name it, let's name this as a, what is this? X. Angle 1 is fine, I think. 1, 2, 3. So please find the angle 1, angle 2, and angle 3. Amira, can you please suggest me like how do you approach this question first? Okay. Okay. Amira, do you have any answers? Okay. Okay then. So let me explain. Okay, and I think Joseph answered here. Let me have a look, Joseph. So you said, I mean, so you know that angle 2 is same as angle this one. See, these two are the vertical angles. So those two are equal. So the first thing, you got the angle 2 as a 20. I think you answered correctly. Let me have a look there. Yeah. And then you know how to find the angle 1, which is 90 minus 40 in a simple way, which is 50 degrees. So sum of three angles add up to 180. So 90 plus 40, take away 1 from 180. So on the other one, 180 plus 40, 110 plus 40, take away from 180. So you said 30, right? Yeah. That's it. Amira, do you understand that, or you want me to explain step by step? You want me to explain? I can't hear you properly. Please chart.
Yeah, you can say.
Okay. So first thing, just take one triangle. See, I'm taking this one triangle. So you know that this is a 90 degree, and one more angle is given 40 degree. So to find the missing angle, I think you know that the sum of three angles is 180. So you need to subtract the remaining angles, which is 90 minus 40. So 180 minus 90 is 90. 90 minus 40 is how much? 50. So that's an angle 1. Okay. So that was the angle.
Yeah.
And how to find the angle 2? Yeah, so the total angle is 180. So we just need to subtract the given angles from 180. The voice is breaking. Can't hear you, really can't hear you, sorry. So please let me know, please, if you have any questions. Seriously, I didn't hear you.
So you're asking angle 2, we need to subtract 90 minus 40?
No. We are not subtracting 90 minus 40. See, for example, let's say the angle 1 plus one angle is given 90 degree, the other angle is given 40 degrees. So which means the triangle has three sides, which means three angles rather. So three angles add up to 180 degree. So which is 90 plus 40 plus angle 1 equals to 180. What is 90 plus 40? Which is 130, right? So angle 1, so I'm writing angle 1 plus 130 equals to 180. And how do you find angle 1? You're going to move that 130 to the other side, which is 180 minus 130. So if you subtract that, you will get angle 1 as a 50 degrees. Okay, that's what I mean to say. Okay, we have a different ways of doing, but please stick to this common method. Okay, and then how to find the angle 2? It's very straightforward. Okay, I will answer that. Joseph. Yeah. So angle 2 is nothing but the opposite angle. So whatever the angle we have here, which is same. So angle 2 is an opposite angle. So opposite angles are equal. And the same thing you need to follow here.
Okay. It should be both should be 40 because opposite to each other.
Yes. Whenever the angles are opposite, always equal. Okay. And then to find the angle 3, we just need to add I mean, you need to add the given angles, which is and then you need to subtract 150. How we need to find this? Okay, so let me answer your question, Joseph. Triangle, so shouldn't, okay, so you thought the second triangle is isosceles, okay, so it might be, but in this case I thought the different 40 and 30, you can see the difference, I think, but by looking at the triangle, I think you are saying it looks like isosceles, isn't it?
Yes, sir.
Isn't it? Yeah, but that's fine, okay, but you can think, I mean, by looking at the diagram, but as per the question, you can see the difference of angle, but maybe it's not drawn precisely, right? Yeah, that I hope you understand.
Yes, sir, I understood that.
Okay, great. Okay, so let's go back to the our topic, so which is the parallelogram. So because of this vertical angles, I went so far. So vertical angles is nothing but an opposite angles. Okay, the opposite angles are always equal. So here, this angle, the A and A is equal, B and B is equal. For example, if we have a parallelogram like this, I'm just drawing roughly, guys. You can see that if this angle, one angle is given as a, let's say, 80, and this one becomes an 80. Okay, because that's an opposite angle. And I hope you know how to find the other two angles, because all three angles add up to 360. So this 180 and 80 and 80 becomes 160. So we're left with 200. So these two angles are 200, rather sum of these two angles. So each angle is 100. So these two are opposite angles. As you see, the angles are equal. Do you understand that, Amira? Okay. And then the rhombus, and then the rhombus. So it looks like this. It is also called as a diamond in most of the cases, and the same properties, you can see that all the sides are equal in length. It looks like a square, but it isn't it. And we can say each angle has 90 degrees if it is a square, if it is if all the sides are equal. If not, angles, opposite angles are equal. So that becomes a parallelogram then. And then kite, remove my writing. Yeah, this is how it looks like, the kite, and you can see that it has four sides, four vertices, two pairs of sides are equal. Okay, it has two pairs of sides, but those two are equal, as you see, the lengthy sides and the smaller sides. You can see that, and total angles are add up to 360, and but the diagonals, whenever the diagonals intersects, that becomes a 90 degree. Okay, that I will explain now. And the formula for kite, I mean, to find the area, it is half of the sum of diagonal angles, which is, let's say the diagonals are A and B, so you need to add those A and B and divide. Okay, we'll try some questions if I have time. Finally, the trapezium looks like this, the isosceles trapezium and the normal one trapezium. So isosceles, in a sense, the top, I mean, the left side and the right sides are equal, but in the normal one, you can't see that same. But opposite sides are different in length, you can see, but it is a parallel, the bottom one and the top one, I mean to say. And the formula is a very interesting one. So have a look at this. To find the area of a trapezium, we just need to add the base the top one, the bottom one, then we need to divide by 2, then we need to we need to multiply by height of that trapezium, guys. But the perimeter won't changes, okay, because it's always the sum of all the sides. Okay, so irregular quadrilaterals, and you guys know that, right? So sides are different, or angles are different. So we have the other types of quadrilaterals such as convex, concave, concave and intersecting. That's how it looks like, okay? It's not important. We hardly get these questions, but try to remember the convex, concave, and intersecting. Okay, so how it like? So you want me to explain a little about this? The convex, in a sense, it's a normal one, irregular one. Okay, all the sides are different, but concave, in a sense, one side will go inside. Okay, one side will go inside the shape and it looks like this. Okay, it looks like this. So that's why it's called as a concave. And intersecting, I hope you know that, the one which we tried just now in the what here in the board, you can see that this is the intersecting one. Intersecting the you can see a four-sided, but we don't have more than 4 sides, I think, in this, right? I think you know that. So this is one side, if you want to say one, and the other 2. So I mean to say this one and this one. So how many sides it has? It has 4 sides. So 1, 2, 3, and this one is a 4. So it is nothing but the intersecting. So this is an intersecting point. So we used to call it as a intersecting quadrilaterals. Yes, that's it of today's webinar, guys. Please let me know if you have questions. Amira, Joseph, any questions?
Nothing, sir.
Okay. So then quickly try some questions, if you don't mind. What is the name of this quadrilateral, guys?
Rhombus.
That's excellent. And you can see that the opposite sides are equal. Rather, sorry. Opposite sides or opposite angles are equal. It's 130, 130, and 50 and 50. Okay, that's a good start. Then what is the name of this? Okay, this is the very simple questions. What is the name of the quadrilateral, guys?
Height. And the next one, trapezoid.
Yeah. Excellent. Yes, yes. What about this irregular shapes, irregular polygons, you can say. But can you please tell me what is the angle of D? What is the angle D here? I hope you guys know what to do. So we know that sum of all the angles add up to 360. So you're going to find the missing one. Amira, do you know how to solve that? Just add 55. All the angles.
So we need to solve all sides.
Yeah. So we just need to add all the angles.
We need to solve all the sides.
Yeah. Yes. So if we add all the angles, all the given angles, we will get 305. Yeah, and then we need to subtract from the total. All 4 sides add up to 360, so we'll get 55. Yes, Joseph, whatever you said is correct. That's excellent. So the angle D is fine. So the next one, guys. So only one angle is given, Joseph, here. But how do you find the remaining angles? Since it's a parallelogram, I think you might have an idea. So how do you find? I mean, it's not about finding angle here. Please find all 3 angles.
So B is 51.
Yeah. So B is 51. Can you tell me the reason why? I think you know.
It's opposite to each angle.
Yes.
What opposite?
Yes.
Same.
Excellent. Yes. Yes. Opposite angles are same. So B and D are opposites. That's a good one. So what about A and C?
So I think it's 129.
51 and 50. Okay. So 51 and 51 is 102. So just take away 102 from this. We'll get 258, right? And then you're going to divide by 2. You said 129. That's good one. Okay. So just given one angle here, and see we are able to find the remaining 3 angles of a polygon, of a parallelogram rather. Okay. I think I have a few more questions. I think. Yeah. The first one. What is the angle B? How do you find the angle B? One thing, angle B and angle D are equal, guys.
Yeah, I think they both are equal.
Yeah.
So 88 minus or plus,
Plus.
I mean minus
Plus.
64
No, plus
plus
64.
64.
Yeah.
88
Then
plus 64.
152.
Yeah.
Take away from 360. Yeah. So we'll get 424. I think 424 divided by 2, which is 212. I think that's what. Okay, I added. Sorry, guys. I think you're right. You're right, Joseph. Yeah. So next one.
So 59.
Okay. So it's a very striped. No. It's not a 51. I think. No, it's not a 51 here. It's isosceles trapezoid. So where are the opposite angles? We can't say it's an opposite angles, right? See, these two are equal. We need to find these two. So these two angles are same. You understand that, Joseph? So 61, 128 take away, I mean 360. Yeah. 121, right? You said, okay. So 242 will get, okay. Yeah, 121 is the correct one. Okay. These questions are okay. So if you want to try the first two questions, please go ahead and try. Calculate the size of a interior angle of a regular regular hexagon. How many sides the hexagon has? So 720 is the answer. So 6-sided shape. You mean
6 sides.
okay? Yeah, that's so. That each angle is 120. So, but here, Joseph, I think they haven't asked the sum of angles. I think, right? They asked you the size of the interior angle. Okay, so if they ask you sum of interior angles, you need to say 720. So it's the size of interior angle.
6 minus 2 multiply 180.
Yes, and then you need to divide by the total 6.
Yeah.
Total size, which is 6. I think Joseph understands that. And then the next one, guys. So in this question, as you see, they clearly asked you what is the size of or the sum of interior angles. I think we already tried the same question, 1080 degrees. So please don't try the third question. Please try the fourth question if you will. A pentagon. So what is the size of exterior and interior angle? So it's not about sum, it's about the individual angle. The sum of interior and exterior angle of a, find the interior and exterior angle of a regular pentagon. Pentagon has 5 sides, guys. So I think you got the answer. So what is the answer? What is the interior angle here? Sum is
Exterior 72.
no. Exterior 72, you mean to say? Okay, that's good. That's good. That's very nice. But what about interior?
I think so 540.
No, they're not asking the sum again, Joseph. So they're asking the each value. I mean each angle value. Okay. So if they ask you sum, they will clearly mention the sum of interior angles. Okay. Or else you need to write the each angle. So exterior would be 72 as you said, but the interior is 108, which is 540 divided by 5. You understand both?
Yes, sir.
How to find the size? Okay, so you know that 540 is the total sum of interior angles. You need to divide by the total sides. Total sides are 5, right? So what is 540 divided by 5? You understand now, Joseph?
Yes, sir. Thank you, sir.
Yeah, great. So that's it, guys. I hope you guys are able to follow me in the webinar. So thank you so much, and please take care of yourself.
Bye, sir.
Yeah, bye. Take care, guys.
Thank you, sir. Have a nice day. Bye.
Same to you. Take care. Bye.